Welcome. Today I'm going to talk to you guys about variable relationships. And I'm not talking about that person you dated for a little while and then decided to go to prom with, and then it didn't work out, and then you never talked to them again, but then now you see them in study hall. I'm not talking about that. I'm talking about variable relationships or relationships between variables, typically in what we would use in this class as an experiment. Um, we want to look for the most obvious, the easiest ways to determine what kind of relationships we have between two different variables. And the easiest way for humans to do that is through graphing. And so we're going to talk very quickly about the types of things we might see when we're graphing out two variables against each other. So I want to officially welcome you to 005 variable relationships. You have to excuse me, I have a little bit of a sore throat today, so I'm going to do the best I can with it. So let's get started. First, question is, how do we know that variables are related? Well, it's pretty easy in a data table to see that there is usually some sort of relationship, at least in general terms. For example, in a data table, you might see that one variable goes up and the other variable goes up as well. So it's easy to see general types of trends. But for more specific, more mathematical relationships, we really need to do something a little bit more. And so that's what we're going to take a look at here. Before we get started, it's important to know just a couple of terms. First term, of course, is the independent variable. Again, this might be a review for many of you. That's totally fine. Independent variable is the one that you choose, right? You choose it. And typically in this class, it can be anything, but typically in this class, it ends up being time or position. Or if you don't like the word position, we'll also use distance or displacement, other terms that are related. So typically we end up with one of those two things because they're the easiest things for us to measure and to choose. It's easy to say I'm going to measure something every 1 second, or I'm going to measure something every 10 centimeters. Those are very simple things to do, and we have very accurate and very precise measurement tools for those. Stopwatches tend to be the most accurate devices we have, and then meter sticks tend to be extremely accurate as well if they're read correctly. Now, once you've chosen those values for your independent variable, they should result in changes, if there's a relationship, in the dependent variable. Again, assuming everything else is controlled. So this is the one that changes in response, or does not change in response if there's no relationship. That's what we want to know. Okay. Now, what could this one be? It could be just about anything. In this class, it could be position still. It could be speed or velocity. It could be force. It could be energy. All sorts of different examples. And we will use all of them at some point. Typically, not always, but typically we choose to make the independent variable the variable that we will list on the x-axis. And typically, but not always, we choose to put the dependent variable on the y-axis. There are very good reasons for why we might want to switch that sometimes, and I will try to point those out to you as best I can. They make your analysis just a little bit easier. So I'm going to go ahead and post up a data table right here. I want you to take a look at it. The data table is a table that was gathered from an experiment in which the mass of a marble was tested against the size of a crater it produced in a model of moon dust. So you can use flour in the physics lab or the astro lab to try to mimic the qualities of moon dust. And so if we want to try to see how the craters on the moon were created, we can impact certain masses on a bed of flour to see what happens as a result. So somebody did that. This was not mine. I just pulled this off the internet. And so what you have is the person chose the mass to be the independent variable. So that's easy to choose, right? You can choose marbles of different masses. That's pretty simple, pretty straightforward. We will also occasionally have mass in there as well. So I should put that there too. And then as a result, the size of the crater was measured, and that's the dependent variable. So you can see there's a relationship between the two there. What is the nature of the relationship, though? Well, without doing something more to that data, it's really hard to tell. So what we end up doing in physics, 95% of the time, is we create what's called a scatter plot. And a scatter plot is something that looks like this, where we have the x-axis here, which is also usually the independent variable. And then we have the y-axis there, which is usually the dependent variable. And then as a result, we plot out our data like so. So let's say that's our data right there. Obviously, I just randomly selected those. So there's our data on this scatter plot. So this is a scatter plot. Why is it called a scatter plot? Because we've sort of scattered the data points all over the XY plane right there. I type or write scatter plot as one word. Some people do it as two words. Some people use the phrase XY scatter. It means the same thing, so it's not really a big deal. If you're using a data analysis tool and it asks you to do an XY scatter, that's what it means. That's okay. Either way is fine. I think, if I remember correctly, Google Sheets does scatter or plot as two words, but don't hold me to that. So why do we do this? Well, because if we plot out the data points where the independent variable is, let me use yellow here, independent variable value looks like this, and the dependent variable value looks like this. We plot out those data points. All of a sudden now our brains, which are very visual, very pattern-oriented, in fact, a lot of our brain is set aside for developing patterns in vision, right? That's how we survived as potential prey years and years and years ago. So our brains are still very visually pattern oriented. So you can see your brain automatically finds that there's a pattern here, and it looks like this, like so. So I've drawn a line. Now notice I didn't connect the dots. We don't do that in physics. This is not middle school. We don't do that stuff. There's a very good time to do that, but it's not now. For us, we use what's called a best fit line. Best fit line. So that's how I will refer to it. It's a line that sort of takes the average position throughout that entire data set right there. You might see, like on Google Sheets, you'll see it calls it a trend line. You also, if it's not linear, you might actually see a best fit curve as well. And we'll have best fit curves plenty of times in this class when we have things that are related, not in a linear fashion. Either way, those are the same things. Best fit lines, best fit curves, trend lines, those are all kind of the same thing. So this line right here, this best fit line, tells us the nature of the relationship, because when you have a line, you know that you can take that line and then you can convert it into y equals mx plus b format. So now all of a sudden, instead of having just a data set of scattered points, you have a line which you can then convert into a formula. And that formula then is going to give us what the relationships actually are. So we see the relationship in a numerical or mathematical sense is actually easiest to determine when you have the ability to create this best fit line because you can convert it right into a formula. If it's curved, then you can use a different kind of formula as well. So we can get more into that later on. Okay, moving on. So the question then is, how do the common relationships appear? And so I'm going to draw 5 common relationships here, so bear with me. They're things that you're going to see pretty often in here. The first one looks like this. Okay, there's our XY scatter plot, and it just looks like this. It's a line, and in fact it's a line with a positive slope. So I'm going to call it positive direct. Because the two variables are directly related. They have a linear relationship. There we go. There we go. And as you saw before, the relationship here is y equals mx plus b when m is positive. Okay. So that's our first relationship. So if we have that linear up to the right kind of relationship, we know we're dealing with a positive direct. Next relationship, again, we'll draw our XY scatter here. And again, this is probably a review for some of you guys. That's totally okay. So there it is. We have, again, a linear relationship, but in this case, it's down and to the right rather than up and to the right. And so we call that one a negative direct. Negative direct or negative linear relationship. Some people just call it a negative relationship, but you have to be careful about that. Again, it's y equals mx plus b, but in this case, m has to be negative. There we go. Okay, next one. Again, I'm going to draw my XY scatter plot here, like so. There we go. And we have a curve, in this case, that starts up here. And then bends down like so. Now this one has a special relationship. It's called an inverse relationship. So you have to be careful between negative direct and inverse. They are similar in some ways, so you have to be very careful about them. But an inverse relationship has a different formula, and it is y equals k, some value k over x. So as 1 goes up, let's say x goes up, y is going to go down. It's similar to this, where as x goes up, y goes down. But in this case, you can see mathematically, this is just multiplying it by a negative number, whereas this is flipping it over the fraction. So they have a different relationship. So just be careful about it. If there's any bit of a curve to the relationship, it's going to have to be inverse, not negative direct. Okay, next one. Almost done here. Got just 5 we're doing. So there's our XY scatter plot here. There it is. And then we have a relationship that looks like this, where the curve goes like so. Now this is not, you can see it's not linear, and it's not inverse because that the curve is going the wrong way. It's actually exponential. We have a few exponential formulas that we're going to cover in the class, so you have to be careful about this. It's a little trickier to determine this, but it definitely is exponential if it has that curve. And what do we mean by that? We mean it's the y equals some number k times x squared. If it's a little bit more narrow curve, then it might be x cubed and so on. But in this class, we'll never get away from just squared. So you can be happy about that. We don't have to worry too much about what's about any really crazy relationships. And then the last one is the simplest of all. You'd be happy to know. Looks like this. Sometimes you get a line that goes perfectly horizontally. Sometimes you have just data points that are all over the place and there's no discernible relationship, and the answer for that one is there's no relationship. So there's no formula that goes with it. Why would a horizontal line be an example of no relationship? Because it doesn't matter what you do to the x value, the independent variable, the dependent variable doesn't change. That's pretty simple. So every formula that we learn, every experiment that we do is going to have one of these 5 relationships. So it's a good idea to get those pretty well memorized if you haven't already. And the formulas that go with them are actually crucial as well. So take that into account when you take a look at it. Okay, almost done here. So if we're only measuring a single variable, we have to do things just slightly differently. So I want to make sure that you guys have that as well. So single variables, we're not looking for a relationship between 2 variables in this case. We're looking for just one variable. The place where this is going to come up often here is when I post up the grades for tests. If I post up the grades for a test, it doesn't make any sense to try to put it on an XY scatter plot because I don't have any I don't have any independent variable to measure, right? So what I would do then is have, instead of having the dependent variable on the y-axis, I have what's called the frequency. How many times the value falls into a certain range. And then on the x-axis here, I have ranges. So let's say I have, if we're using the test example, I have A's, and then I have B's, and then I have C's, and then I have D's, and this never happens, so I'm going to put it down. But just keep in mind, nobody will ever get there. Got F's right there. And then you can have low F's if you want. Let's go ahead and put a sad down arrow right there. So the question then is, now I have the values, I have ranges for the values for the dependent variable, and I have the frequency that it falls into each range. So let's say I have, in this case, let's say I have 5 people get B's, like so. And then I have 12 people get, I'm sorry, that was 5 people get A's. I don't know if I said that. And then, let's say 12 people get B's, like so. Ooh, my pen is struggling to keep up with me here. And then let's say another 7 people get C's. Okay, and then well, let's say we don't want it to happen, but let's say for sake of argument it does happen that we have 3 D's. Okay, so it looks like a bar chart, right? But in reality, it has a special name when you do it this way, where you have a range of values, and then you calculate the frequencies in each range, and that is a histogram. And so it doesn't happen very often in physics that we're going to be trying to measure out histograms or try to come up with histograms. But it does happen a lot of times in engineering and manufacturing. So, and you'll see this, you'll see a histogram after every quiz and every test to see how people did. We're going to talk about how to analyze histograms more when we get to doing our first one for real. So hopefully that makes sense. Okay, so with that, it's been long enough. I'm going to go ahead and wrap it up. So I wanted to thank you guys for watching. Again, don't forget to fill in those note sheets and your question forms. Those question forms, remember, drive our discussions the next day, so we want to make sure that you guys have that in there. If you have any further questions on this, something we're going to be talking about often in this class. It's going to come up again and again, basically weekly with every experiment that we do. So you want to make sure you know what you're talking about. Again, if you have questions, please go ahead and ask and bring them to our discussion on our next day. Thanks. Hope you're having a good one, and good luck.